A digital circuit shown could be replaced by which logical gate device? Okay, so you basically have a circuit over here, and the question is, can we replace this circuit or transform this circuit by using some other logic gate, say OR gate or NAND gate or something else? Now, before we get to this question, to the meat of it, you need to understand DeMorgan's law. And what does it state? Now, DeMorgan's law state that A dot B and bar on the whole thing is equivalent to A bar plus B bar. And similarly, A plus B bar on the whole thing is equivalent to saying A bar dot B bar. Now, what these conventions are, dot and plus. Well, know that dot just simply is a multiplication or product, which basically implicates AND gate, right? And OR is just adding, so it's an OR gate. So notice over here, if you look at it in its textual representation, the symbolic representation, you have A dot B bar on the whole thing. You have an AND product here, and it converts into OR. So what's happening over here? So a textual representation of what you see over here in its symbolic form is we basically invert the inputs and outputs. We invert the inputs and outputs. And in the second step, we replace the AND gate with OR gate and vice versa. If there's an OR gate, replace it with the AND gate. If there's an AND gate, replace it with the OR gate. So notice over here, if we apply these two rules over here, let's look at again. A dot B bar on the whole thing, right? So A is going to be inverted. You have the A bar now. B is going to be inverted, B bar now. Dot will be replaced by a plus sign. Okay, and this whole bar is just simply gone, right? Similarly, A plus B bar on the whole thing. Input A is going to be inverted, so you have bar here. B is going to be inverted. The plus sign is going to be replaced by a dot, right? Now let's look at the circuit right here. You got A, B inputs. They go into inverters, so it becomes A bar, B bar. They go into AND gate, and there's another inverter. So you basically get A bar dot B bar here. And because it's going through an inverter, so it becomes A bar dot B bar and then bar on the whole thing, just solely because of this inverter, correct? I can transform this circuit for an easy explanation. Instead of using these inverters, I can use this bubble, right? Bubbles are basically inverters as well. So A has an inverter, B has an inverter, and then at the output of the AND gate, there's another inverter. So I'll just use a bubble, right? Now we are going to apply these two rules over here. What other one? The first is invert the inputs and outputs. Because there is a bubble here, I'm going to remove a bubble. Because there's an inverter here, I'm going to remove the inverter. Same thing. Similarly, B also has a bubble. I'm going to remove the bubble here. At the output, there's a bubble. I'm going to remove that as well. Next, replace the AND gate with OR gate. All I need to do is replace this AND gate with the OR gate, and that is going to be equivalent of this circuit that you see, the two circuits that you see at the top. And we can just verify it very quickly. Say you got 0 here and 0 here. A and B both are 0, 0. Because there's an inverter bubble here, this becomes 1. This becomes 1. 1 and 1 going through an AND gate gives you 1. And because there's an inverter here, it becomes 0 here. Correct? Because of the inverter, it becomes 0. 1 becomes 0. Now again, same inputs. 0 here, 0 here. What is the property of the OR gate when both inputs are 0? You get 0. Both outputs are same. That means they both are. I can try one more combination. Say we go with A being 1 and B being 1 as well. You have the inverters, right? So this becomes 0, 0. 0, 0 going through an AND gate becomes 0. And then at the output, you have this bubble. Invert of 0 is going to be 1, right? Similarly, A is 1 here, B is 1 here. 1 and 1 going through OR gate is going to give you 1. So you get 1 here and 1 here. The two outputs are same. So this gate can be replaced by a 2-input OR gate. Very simple. And it will help you get rid of the 3 inverters. That means less transistors on your circuit. Switching speed becomes faster, size smaller, save on cost.